A journey through the forest, ecological interactions, and indigenous perspectives. Imagine walking through a forest, the thick air with the scent of pine, the rustle of leaves underfoot, and the vibrant calls of wildlife filling your ears. But as you pause and take in the surroundings, a deeper connection begins to emerge. One that links not only trees, the animals, and the soil, but the very principles that govern the interactions. This is where the science of ecology meets the wisdom of the land. In this reflection, I'll take you on a journey through the forest ecosystem, exploring the ecological concepts of abiotic and biotic interactions, evolution, and how both Western scientific knowledge and indigenous perspectives enrich our understanding of nature. From our first lecture, we learned that ecosystems are dynamic systems shaped by both abiotic and biotic factors. The temperate forest, with its towering trees, nutrient-rich soil, and vibrant wildlife, perfectly illustrate these interactions. This ecosystem operates as a network of interconnected niches, where each ecosystem has a specific role to play, a concept we explored in Lecture 4. For instance, certain tree species dominate the canopy, capturing sunlight and creating shade, while the understory plants adapt to these low-light conditions, showcasing niche differentiation. This structural complexity allows biodiversity to flourish and resilience to persist despite disturbances. The distribution and abundance of species here aren't random. As discussed in Lecture 6, abiotic factors like temperature and soil composition influence which species can thrive. For example, the soil's pH can determine which plants grow. In turn, these plants shape the habitat for insects and small mammals. Biotic factors like competition for light resources further regulate species population and their distribution across forests. Evolutionary processes are the foundation of biodiversity and ecosystems like this forest, a concept we explored in Lecture 2. Species evolve through natural selection, adapting to environmental pressures over generations. For instance, the woodpecker's specialized beak evolves to access insects deep within the bark, filling a niche that minimizes competition. Similarly, flowers have co-evolved with pollinators, developing bright colors and nectar to attract bees to ensure pollination, a mutualistic interaction critical for forest regeneration. These evolutionary adaptations often lead to speciation, where new species arrive from common ancestors. This is evident in forest ecosystems, where isolated populations of plants or animals may adapt to microhabitats, eventually becoming a distinct species. As we discussed in Lectures 7 and 8, these evolutionary processes are tightly linked to population size, reproductive strategies, and carrying capacity of the environment. Behavioral adaptations also play a crucial role in evolution, as highlighted in Lecture 3. Predators like hawks have developed sharp talons and keen eyesight to hunt efficiently, whilst prey species such as rodents have evolved behaviors like burrowing or camouflage to evade predators. These evolutionary arms race demonstrate an intricate balance of life within ecosystems and how species interactions drive adaptation. Now, as we explore these scientific concepts, it's important to understand an indigenous perspective, etowoptimum, or two-eyed seeing. This principle, deeply rooted in the Mi'kmaq worldview, encourages us to use both Western scientific knowledge and indigenous wisdom to guide our understanding of the natural world. Through the lens of etowoptimum, we not only see the forest through a scientific concepts of abiotic and biotic interactions, but through the understanding that nature has a spirit, a purpose, and a role in the balance of life. The forest is not just a collection of plants and animals. It's a living entity that we must respect and protect. This mindset shifts how we engage with nature, emphasizing sustainability and sacred relationships we share with all living things. So why do these ecological concepts and indigenous perspectives matter? They shape our approach to environmental conservation and sustainability. By understanding evolutionary processes, abiotic and biotic interactions, and embracing etowoptimum, we can make better decisions for health of our ecosystem. We see the interconnectedness of life and the importance of preserving biodiversity. Through this course, I've come to realize that every action we take in the environment has a ripple effect. Whether it's conserving the soil that nourishes our plants or protecting the species that rely on it, we have a responsibility to maintain the delicate balance of our ecosystem. And as we've learned, integrating both scientific and indigenous knowledge creates a holistic approach to solving environmental challenges. In conclusion, the journey through the forest ecosystem has not only taught me about the science of ecology, but also the importance of recognizing multiple ways of knowing. By using both Western sciences and indigenous wisdom, we can ensure that we protect our ecosystems for future generations. Thank you for joining me in this exploration. Let's continue to learn, respect, and care for the world around us.